Isaac Newton was a brilliant scientist. He was born in England in 1643. Newton changed the way we understand the universe. He developed calculus, a new branch of mathematics. He also discovered the laws of gravity and motion. Newton's laws of motion explain how objects move. These laws are fundamental to physics. They help us understand everything from the motion of planets to the motion of cars. Newton's work laid the foundation for modern science. His discoveries continue to inspire scientists and engineers today. His laws of motion are a testament to his genius. They are as relevant today as they were centuries ago. Newton's first law of motion is about inertia. Inertia is the tendency of an object to resist changes in its motion. The first law states, an object at rest stays at rest. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Imagine a book resting on a table. The book will not move unless a force acts upon it. This force could be a push from your hand or a gust of wind. The book's inertia keeps it at rest until a force overcomes its resistance to motion. Newton's second law of motion explains how force affects motion. It states, the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. This means that a larger force produces a larger acceleration on an object. A heavier object will accelerate less than a lighter object under the same force. Imagine pushing a shopping cart. The harder you push, the faster the cart accelerates. If you add more groceries to the cart, making it heavier, you will need to push harder to achieve the same acceleration. Newton's third law of motion describes the relationship between action and reaction forces. It states, for every action there is an equal and opposite reaction. This means that forces always come in pairs. When one object exerts a force on another object, the second object exerts an equal and opposite force back on the first. Think about jumping off a diving board. You push down on the board, action. The board pushes back up on you with an equal force, reaction, launching you into the air. Section 5. Newton's laws in action, from sports to rockets. Newton's laws of motion are everywhere in our daily lives. They explain why we wear seatbelts in cars, they explain how airplanes fly, they are even at work when we walk or throw a ball. In sports, athletes use Newton's laws to their advantage. For example, a baseball pitcher uses his arm to apply force to the ball, which is Newton's second law. The faster he moves his arm, the greater the force and the faster the ball travels. Similarly, a swimmer pushes off the pool wall, which is Newton's third law, to propel herself forward. Rockets are another great example of Newton's laws in action. The rocket engines burn fuel, producing hot gas. This gas is expelled downwards with tremendous force, again showing Newton's third law. This action propels the rocket upwards. Section 6. The significance of Newton's laws. Newton's laws of motion are fundamental to our understanding of the universe. They are the cornerstone of classical mechanics, a branch of physics that describes the motion of macroscopic objects. These laws have applications in countless fields, including engineering, astronomy, and sports science. Engineers use Newton's laws to design bridges, buildings, and vehicles. Astronomers use them to predict the motion of planets and stars. Sports scientists use them to analyze athletic performance and design training programs. Section 7. Beyond the basics, exploring the limits. While Newton's laws are incredibly powerful, they do have limitations. They work extremely well for most everyday objects and phenomena. However, they break down in extreme conditions, such as at very high speeds, approaching the speed of light, or in very strong gravitational fields. In these extreme realms, Einstein's theory of relativity provides a more accurate description of reality. However, it's important to remember that Einstein's theories did not invalidate Newton's laws. Instead, they extended and refined our understanding of the universe, showing that Newton's laws are a special case of a more general theory. Section 8. Newton's legacy, a foundation for the future. Isaac Newton's work revolutionized science. His laws of motion provided a framework for understanding the physical world. They allowed scientists to make accurate predictions about the motion of objects. This led to countless technological advancements, from the steam engine to the smartphone. Newton's legacy continues to inspire scientists today. His emphasis on observation, experimentation, and mathematical reasoning remains at the heart of the scientific method. His work serves as a reminder that the universe is governed by laws. By studying these laws, we can unlock the secrets of the cosmos. Section 9. Conclusion: the enduring power of simple laws. Newton's laws of motion are a testament to the power of simplicity. These three laws, elegantly stated, have had a profound impact on our understanding of the universe. They explain everything from the motion of a ball to the motion of galaxies. As we continue to explore the cosmos and develop new technologies, Newton's laws will undoubtedly continue to guide us. They are a reminder that the universe is a comprehensible place, governed by laws that we can understand and use to our advantage.